Okay, folks, now we're going to look at the continuous stuff that we talked about. So again, let's do the back side of that sheet I handed out to you. So here's what we got. People playing Minecraft. And what it says is, when we look at this, people are playing Minecraft. The distribution is approximately normal with a mean of 150, a standard deviation of 42. So mean of 150, a standard deviation of 42.7. Hopefully this looks a little familiar because actually we did this already. We did this way back, and I think it was chapter 2. Chapter 2 is where we did this. So is this a discrete or is this a continuous variable? Well, what I'm going to tell you is that y is continuous. And the reason that y is continuous, because what we can do in this case is we can have any value from 0 to 1440. And again, 1440 is because there's 24 hours in a day, and that's how many minutes there are. 0 to 140 minutes can be spent playing Minecraft. So again, what you want to think about is this. A continuous one is where you can fall anywhere on the number line. So technically you could play 7.2 minutes, 8.1 minutes, 6.11112 minutes. Like you could play anywhere there. That's continuous. So that's why we call that guy a continuous variable. Interpret the standard deviation, kind of like what I did when I did for discrete. It's the same idea. It's basically the amount of time spent playing Minecraft each day. Spent playing Minecraft each day. Playing Minecraft each day. Typically varies by 42.2 minutes. From the mean of 150 minutes. So that's our standard deviation. Now, what I want to talk about now is what we're going to talk about is this idea of how we figure out all these probabilities in a continuous. And if you think about it, what it's going to be is it's going to be doing this kind of guy. We're doing this normal curve. And if you remember, when we do the normal curve, what we end up having is we end up having a mean and a standard deviation. So what's going to happen here is I'm grabbing my note. Over here, the mean goes in the middle. What we're going to do is add 42.7, subtract 42.7. So this guy's going to be 192.7. Then we're going to have 235.4. And then last, we're going to have 278.1. And then we're going to subtract our 42.7, which is going to give me 107.3. 107.3. And then it's going to give me 64.6. And finally, it's going to give me 21.9. So there's our plus and minus 3 standard deviations. And what we're looking at here is, again, we're looking at the probability that we're less than or equal to 90, the probability that y is less than or equal to 90. So this is saying the probability that we're at 90 minutes or less. So this is our 90. What is the probability that we're there? First way I'm going to show you is using z-scores in the table A. So z equals x minus mu over sigma. So in this case, x is our data value. So in this case, it's the 90 minus 150 is our mean, divided by 42.7, which is our standard deviation. So z is going to equal negative 1.41. So that tells me this guy has a z-score of negative 1.41. He is 1.41 standard deviations below average. You can then break out table A. And when you look at table A, you're going to go to negative 1.4, the 1 column. And that's going to tell me that the answer is 0.0793. So from table A, what we're going to find out is that this probability is 0.0793. That's where we got that number. Now, the other way you can do it is you can do it with your calculator in its Normalcdf. And the arguments in Normalcdf are lower bound, upper bound, mean, and standard deviation. And it is in your calculator where you do second, vars 2, which is normal CDF. So in the calculator, I'm going to do normal CDF. My lower bound here is there is none, so it's negative lots of 9s. My upper bound is 90. That can get no bigger than 90. A mean of 150, a standard deviation of 42.7. And the big part is make sure you label lower bound, upper bound, mean, standard deviation. So now what I'm going to do is I'm going to go to second vars. I'm going to go to number 2. My lower bound is is real big, a real small number. My upper bound is 90. We got a mean of 150. We have a standard deviation of 42.7. We're going to paste that in, and it tells me it's 0.07999. So this tells me the probability that y is less than or equal to 90 is 0.0799. And if you notice, these two numbers are pretty close to one another. So this is kind of your calculator way. This is your table A way. So let's go ahead and do this one. Again, let me just kind of quickly sketch the picture. So here's our picture. And I'm going to kind of use this as a reference. So this is 150. What's the probability we're between 45 and 90? So 45 is probably right about here. 90 is like right there. We're trying to find an area in between. So the way we need to find that is what we want to do is we want to figure out, in this case, what's the area in between. So let me do the calculator first. In this case, we're going to do normal CDF. We're going to say 45 is our lower bound, 90 is our upper bound, 150 is our mean, 42.7 is our standard deviation, so lower bound, upper bound, mean, standard deviation. So from the calculator, the probability that we're between 45 and 90 is going to be second vars, normal CDF, 45, enter on through. It's going to be 0.0730. So this probability is 0.0730. And if I wanted to go ahead and I wanted to do it by the calculator, by the table A, what I would need to do is I would need to figure out the z-score for each one of these. So I need to figure out the z-score for 90, the z-score for 45. So we know from the first one that the z-score for 90 is negative 1.41. And that gave us an area of 0.0793. So that's what we know from this. Now we would need to figure out the z-score for 45. So we'd need to do 45 minus 150 divided by 42.7. And that's going to give us a z-score for 45 of negative 2.46. And what we need to do using table A is negative 2.4, and then we come over to the 6th column right here, 0.0069. So this tells me that this area is 0.0069. And what I need to do is I need to figure out the difference between those two, because this tells me everything down. 45 tells me just from 45 down. So if I do 0.0793 minus 0.0069, I'm going to get 0.0724. So in this case, the probability of y being between 45 and 90 is 7.24. Again, pretty close, but it doesn't have to be exact. Either way is fine. Table A is fine, calculator is fine. Most of the students typically go with calculator, but again, I'm not going to stop you if you want to do table A. Talk to me if you want to do table A. It's kind of it's a cleaner way to do it in the sense that you are kind of really getting into the details. But again, College Board is okay with that normal CDF as long as you label everything. So please label them. I'm telling you, if you don't label them, I'm going to be taking points off. If you don't put this kind of thing down, I'm going to be taking points off. Please, please, please do that. Ask questions if you got them in our daily reflection, and have a wonderful Thanksgiving. I'll see y'all in December, or see y'all in a week.